All right. Hello again, everybody. So my name is Imants. I'm from Leonteq, and I'll walk you through our journey to GCP. I'll talk about how we built some new software for GCP and how we migrated some of the existing infrastructure to GCP. Let me introduce Leonteq a little bit. So we are a financial company. We are focusing on two main business lines. One is investment solutions, which is mostly related to issuing structured products. And the second is insurance and wealth planning solutions, which look into the long-term savings products and providing some capital protection for them. So I will talk mostly from the perspective of the insurance and wealth planning solutions division. There are some similarities, but also very big differences between the divisions and how we operate. So this mostly applies to the insurance and wealth planning part. So our systems, or basically also the products which we offer, have some certain characteristics which causes some challenges for us, which might be different from other places. So what we do is we do a business-to-business operations, and we basically do financial calculations and advice for our partners, meaning that we receive some insurance-related data from them. We process and return them back some investment advice. And how this works is that we are managing financial products for insurance policies, which has long time horizon, around 50 years, which means that whatever we build, we have to maintain or in some shape or form keep the system around for 50 years. We have the contracts with the end clients to maintain their policies for this time period. What it also means is a business-to-business solution that the data which we process is mostly coming as batches from our partners, but with some of the partners we also allow them to interact with the system through UI, so they make changes to policies through UI, but those are still relatively low volume of changes, so it's not a public application, right? And then what we have is this daily or monthly calculation process, which operates on the policy data and basically calculates the investments or the allocation, how to invest that money, which is coming from the partners. And this is a CPU-intensive calculation. We basically have to go through all our policies in the system and compute the new positions and suggest the trades which we need to do. Because of that, we also do a lot of testing. We have to be sure that whatever we calculate is right. So depending on which components, but the critical ones, we run some extensive test suites, which on premise can take from 1 hour to 8 hours. So on commit we run the shorter one for 1 hour, and then the nightly one is the longer one. And we have two main systems or products. Or for insurance, which we have been developing on site for long time already, and we have to maintain it and improve. And we are building also a new one, which is more oriented to our banking partners, but the workloads are still similar. It's very peaky, and we need to process lots of data in short interval, and then it's mostly idle. So how we approach the whole development process are basically three main values which we look at. We take security very seriously, and with help of Google's infrastructure, a lot of those things are kind of given out of the box, are much more easy to handle than on-premise, where we have to do everything. And because of the long time period, we really care about the sustainability on how we actually can manage this solution for long term and with minimal effort, and actually focus on business development, not maintainability. And also because of that, we tend to try to keep things as simple as possible. Yeah, not always possible, but that's a goal of us. So from development concepts perspective, we focus on working together with the security teams and operations teams to really streamline the process. We keep all our infrastructure as a code in Git and manage it using the GitOps process. We think about the infrastructure as immutable, so we never go and click in the Google UIs, or at least we do it in our research and development phase, maybe when we try things out. But as soon as we want something to deploy even to dev environments, we work with infrastructure as a code. So we work with microservices and continuous delivery per service. So on premise, that was not the case. We had a bit more like a distributed monolith there. Also microservices, but they were not separated well enough. With the new projects, we build it in a much better design from scratch, and hope we can keep it that way. So we look into using managed services as much as possible. Yeah, and also the audit trail is important for us as a regulated company. So what working with the cloud gives us most is the ability to scale down to zero, because for the workloads which we run like maybe an hour a day and then 23 hours, basically the system would be idling on premise. So we look into solutions in Google where we can actually save money when we are not using the resources. And mostly for testing, we look into running more parallel tests and so on, that we can scale it up, run them, and then scale down again. And with the managed services, what we get also is that we have way fewer people in our team managing the infrastructure and things around it. So we currently, in the development mode, we have 3 developers working on the infrastructure tasks, and maybe not even full time. So from security, what we get, we get all the encryption out of box. We make sure that all the communications are secure between all of our services. We leverage Google's identity-aware proxy for integration to our Active Directory, and we make sure that all the authentication is token-based, and authorization as well. Yeah, we utilize the artifact registry's vulnerability scanning of Docker images. So in order to promote some images between environments. They have to pass the checks. And we are looking also with Kubernetes. So basically what we do is for the new code, for the new services, we use Google's Cloud Run. But for the projects which we are slowly moving over to Google Cloud, it's easier for us to shift them into the Kubernetes cluster. So we have built Kubernetes cluster, the managed one we manage it with Terraform, and it has ASTO and MTLS enabled, and so yeah, this is kind of the big part of the work which we have done. So from environment perspective, so each environment is expressed as some code in Git. So we have like development, UAT, pre-production, and production environments. How by design we have built them, they are basically dynamic in a sense that you can spawn an environment by provisioning the resources, and you can also destroy it. So we have a Git repository which describes how the environment should look like. And then when some changes are pushed, it actually triggers a Terraform-based deployment which provisions those resources. What we have done differently from the on-premise, so our development process has changed in a way that we now develop more on the dynamic environments, basically that users can provision environment for them, use them for a while, and then discard it when it's not necessary anymore. And then there are the certain paths for any code change to get to production with different approvers in the process. And those are then static environments. They are never destroyed. So an example of the Git repo describing an environment would be like a small repo like this. The important part is the ConfigYaml file. I'll show in a minute how it looks like, which describes how the environment should look like. And then there are the cloud build scripts, basically for deploying, destroying environment, and for promoting images between them. And in the case of Terraform code, we tag. I'll get back to that in a moment. So the ConfigYaml in the simplest case looks like this. It says in which Google project the environment should be provisioned, and then you have some services which could be enabled or disabled in an environment, and you have the versions of those services. And in addition, you can have, depending on if the environment is integrated with partner or basically any external environment-specific parameters would go there as well. So when we look at as an environment as a whole, what it is, right? So this is this ConfigYaml, which is describing what the environment should look like. And then there is a bunch of code which is coming with it, which actually gets deployed in the end and makes up the real environment. And so what do we have there is then the cloud build YAML files, which tell us how the environment will be deployed on a high level, basically what steps are there. Then we use a custom built Docker image with some tools which actually do the deployment. And then we have some application images which will get deployed to the environment, and we get some infrastructure code which is expressed as a Git repositories with Terraform modules. So all of these pieces together is the code which we first of all have to secure and then deploy. So all of these components go through our software change process, and everything has to go through a code review and tested and approved before it can get deployed anywhere. On the Google side, what we do is we played a bit around with different ways to structure our projects there, and so this is the structure which we ended up with, that for every business line we have a folder for environment, and then in the folder we have a bunch of projects which each of them is a separate which is managed by a separate Terraform state. So for every application which is set of services, we'll have a Terraform state and the project with the resources which are provisioned for it. And there are some shared things which we share between the applications. We have our continuous delivery related things which are responsible for the promotion process and keeping everything together. And there could be a Kubernetes cluster which is shared between the applications in the environment. How we look at Google resources in general, so basically we say everything is code, right? And everything what we provision in Google is just some sort of resource. And there are simpler ones which you get basically from out of the box Google services like storage buckets, schedulers, and the queues would be the examples which we use. And then it's our software which gets deployed on Google's infrastructure, which has also then our code in addition. But in principle, how we provision the resources is the same. We do it with Terraform, and we specify some parameters how to instantiate this as part of environment. From development process, so we have a slightly shorter process for libraries. It means whenever we have some library, we are mostly a Scala company, so we work with Scala. And for libraries, what we do, it's a simple process of creating a pull request, then some unit tests are run, there is a code review always, and only then when the pull request is merged, we create a tag and publish the artifact to artifact registry. And we treat the infrastructure libraries, which are Terraform code, exactly the same way as we treat our Scala libraries from the process perspective. They go through the same process. And then the second kind is the deployable ones. So this would be the Docker images, which now would be built and then contain inside some of the libraries which were built in the previous step. And these now go through dual promotion process to production. So basically, advanced tests on those libraries would be part of just testing the business functionality here. And how we organize it with the GitOps is through the pull requests to the environment repos. So whenever we want some code to be deployed to an environment, in let's say in this case our user acceptance testing environment, so whenever there is a new artifact built and which has passed all the checks it had to pass, we will try to get it on an environment. So we will create a pull request for environment repository updating, let's say, a service version or the infrastructure code tag, which we want to get on that environment. And for that, we will also generate a bunch of checks in the GitHub, which have to pass before the pull request can be merged. And when the pull request is merged, then the update is merged to the master branch of this environment repository, and it means that then the deployment will be triggered to that environment. And when that happens, we initiate the next step for the next environment, which process-wise is the same. It's just that there will be a different checks which need to pass. So for some code to get to UAT, it's automated, so it has to pass all our test suites, and then it's deployed there, and then there the manual acceptance testing is done, and when the business and QA sign off, then we put it to the staging environment, and then the release management has the final say when we can proceed with it. So how do we promote the changes? So yeah, it's basically the pull request part of it. I explained. We raise a pull request, but also to actually make sure that only the code which is approved for a certain environment can be deployed there. We need additional checks in place. So what we found out, the easiest for us was to create a new artifact registry repository for every environment where we want some code to be deployed. And then we set it up in a way that the deployment job for an environment can only deploy code which is in the repository which it owns. And then the promotion process, when we actually have signed off some code for the environment, we copy the image over to this repository. So we never rebuild. We build the image once, and then we just copy it to the places where we want to deploy it. How this whole thing works together? So we think of it as a three-piece software. So on premise, we used Jenkins for doing most of this, but we didn't see it as a good fit for the cloud. So what we found out that there were pieces not fitting together, or either it was hard to manage in a cloud native way, and so on. So in the end, we ended up with a solution which consists of three pieces, where we have Git as a source of truth of everything. So it's the only state which we have. So there is application code, infrastructure code, all the configuration, all the audit is there. Who changed what? Then we utilize the cloud build as an execution engine which runs all the tasks, the builds, the deployments, and so on. It's set up in different projects and with the access rights that on a finer granular level that only the job has access to building images and nothing else, or then the dev deployment can deploy to dev. And then we have a small application of our own which actually tries to tie it all together, which defines our process and basically fills the gap between the Git and the cloud build. So what it gives, in addition to us, that also the whole pipeline goes through our software and release process. So the code changes to the pipeline, and everything has to go through the same process as everything else. Yeah, so why we ended up there, that we looked at different combinations at the Jenkins, at Jenkins X, at Spinnaker, and somehow when we evaluated it, we couldn't find a good fit. So either it seemed too costly to maintain, or it didn't do exactly things as we wanted. So we ended up with our solution for orchestrating the process. And I think now I can give the floor to Miroszlav to continue.
So let's talk a bit, thank you, Imants. So let's talk a bit about Terraform. So Terraform we use to manage our cloud resources, and it acts like a reconciliation, like a controller, something like in Kubernetes with deployments. So it basically tries to reconcile the state, the desired state and the actual state. So it knows what you want it to do, and it knows the current state, and basically tries to make it as you wish. Then what next do we have? Yes, we use Terraform best practices. So for the code, we use this plugin which does the formatting, does documentation for us, automatic documentation, validation, and length. So we know when we commit the code that the code is actually clean. DNS, we express DNS as a Terraform configuration. We use DNS for the top domain and all the subzones. The subzones we link with the main domain. And the fourth point is we couldn't buy a domain in Switzerland with Google Domains. Unfortunately, we hope to see it soon. So we just pointed the domain to Google, basically. DNSSEC enables us to cryptographically sign the record so that the end user actually knows that the record hasn't been changed. So if you look here, you see one of our zones and the verification, so analyzer of the dot zone, that then ch olap.ch, which is our domain, and dev olap.ch. We use Google Cloud Build, as Imants has said, to build artifacts, to do tagging on the source, to do deployments. We have two types of artifacts, libraries, and proto-gRPC API definitions that we so basically we create jars and push them to Maven artifact registry. And we also do services as Docker images, also pushing to Docker artifact registry. Yes, Cloud Build custom images. Yeah, okay. So we have custom images with all of our tools that we use for tagging, building, and deploying. Yeah. Then we use Google Cloud Run. So why do we use Google Cloud Run? It's managed, so not much really that we need to maintain it. So the reasons are cost, scaling to zero, security, authentication. It's a managed service. It's available in Zurich, I think since a few months ago. But we really can't use it since domain mapping doesn't work in Zurich. So we can start the services in Cloud Run, but we cannot map the domains, which is unfortunate. And then setup is much more simple than in Kubernetes. We set up Cloud Run with Terraform. We have our own Cloud Run module. So something about Google Kubernetes Engine. So basically, we use it to lift and shift the legacy services to Kubernetes. So we have a complete isolated private cluster with Istio that we manage ourselves. Google is actually a few versions behind for their own reasons. We use workload identity, meaning that we connect the Kubernetes service accounts with Google service accounts, and then use IAM permissions. Then we do node pools for different workloads and mutual TLS for all services by default. So we create tunnels. So basically, GK is running in a private VPC, and to be able to use it from the cloud build, we create a tunnel through IaP, so we can access the proxy and talk to Kubernetes API server. This way we can work across networks and access Kubernetes. We use Threat Manager for Let's Encrypt wildcard certificates. This is all running in Istio. Basically, we just get a wildcard certificate once for environment, and that's it. Domain verification we do via the DNS. So we don't have any services that we expose by default to outside to use for domain verification. We just publish a text record in the zone, and that's how Let's Encrypt knows that we are legit. We use identity-aware proxy with external identities. So yeah, we use load balancer also with predefined static IP address. So one load balancer, I believe. Okay, yeah, we use one Terraform apply to both create a cluster and configure it. If you read about the best practice, the way usually people do it, they create a cluster, then the second Terraform apply is to configure it, and the third one is to apply services. So we were able to combine these two into one, and hopefully the third also in some future. We use Helm tree provider for Terraform and Kubernetes provider for Terraform, using proxy URL to access a private cluster. So basically, in kubeconfig, we just add a proxy URL to tell Kubernetes and Terraform to access the cluster. In Kubernetes provider, it works by default. In Helm, we had to configure it a bit, rebuild, and it works. Kubernetes provider for Terraform doesn't support all custom resource definitions like the ones that Istio has. So we decided to use Helm 3 Terraform provider with Helm charts. And the alpha version of the Kubernetes provider looks very promising because it's supposed to work with any resources. So hopefully in some time we can use it. Here you can see one cluster. This is mine, actually, my environment, running in Zurich, so Europe West 6, and with some other details. So as I said, we use the Google Identity Aware proxy. We use it for central authentication, authorization with our LDAP. It provides the details about the current user, about its groups, and then the applications are free to determine what the actual user can do in their own scope based on this groups and user info. And of course, we use external tenants. And this is how it looks like, the icon to sign in to our application. So you basically sign in only once for our oral applications. We use PubSub basically to asynchronously communicate between services. We use Google Cloud endpoints as a synchronous communication between services using gRPC endpoints. And also we expose the services as REST using JSON transcoding by endpoints. Maybe we'll do the same with Istio. It remains to be seen how we will actually do it. Artifact registry, we used to use GCR. Now we use artifact registry for Docker and Maven artifacts. Docker images are promoted between environments, as Imants has said. This is a quote from a blog post, I believe, some time ago, where you can read how we actually use it. So quote by Imants, where he says that migration from on-prem registry to artifact registry has been a very smooth experience. Artifact registry builds upon container registry by providing us a single place to store, manage, secure, and share both Maven and Docker artifacts. And given artifact registry is fully serverless, unlike our on-prem registry, we never run out of space and pay for what we actually use. Artifact registry currently doesn't support Helm 3 for the charts, but I believe it will, by knowing Google, it will happen in the future, probably support for all other artifacts. So I'm optimistic. So artifact registry, here we have an example, like one Docker, one Maven registry that we use in the Zurich region. We use secrets manager, so we have auto-generated secrets and external secrets. Because it's a managed solution, we considered using Vault, but this seems to serve our purpose. We use Firebase for hosting auth application for identity aware proxy, Firestore to store data, which is managed in pay-per-use, cloud functions on response to data, to changes to data, authentication. Data storage, we use the 3 types of data storage buckets because they are cheapest, key value storage. SQL for legacy reasons, so we would like not to use it in use paper query model. And document storage, we use Firestore key value, where we can have indices on other fields in JSON documents and queries on other fields, not just the key field. For logs, we use Stackdriver. It works with the VMs, with Kubernetes, with applications, Google services, so we have one place to store our logs. And our applications output in JSON format where the fields are indexed and available. So some lessons learned. So deploying even a managed GKE with Istio and authentication using Terraform is a huge effort. It took us some time to actually get Kubernetes up and running with an entity-aware proxy. Google Cloud Run is actually much simpler. It's basically Kubernetes and serverless, right? Cloud Run. We use a managed solution, so it's much simpler and can cover most of the use cases we have for microservices with REST, gRPC, HTTP interface. And Terraform is still a work in progress. In 90% of cases, it works great, but then it requires workarounds with external providers, null resources, shell scripts, etc., to fill in all of the gaps. And yeah, now we open for QA if there are any. Thank you very much.
Okay, thank you, Mirosz and Imants. You can shout in the chat if you have any questions. So if no questions, then I would suggest to move on. Okay, so thank you very much to Mirosz and Imants.
Thank you very much.
I wish my computer, my nice MacBook, good recovery. Okay, so thanks you and see you.
Thank you.
Thank you very much.